Hi there, I hope you guys are all doing well on Module 5 so far. We're going to go through the assignment prompt and talk a little bit about how to do some of this stuff. You have been hired by the regional real estate company to help them analyze real estate data. One of the company's Pacific region salespeople has returned to the office with a newly designed advertisement. It states that the average cost per square foot of his home sales is above the average cost per square foot in the Pacific region. He wants you to make sure he can make that statement before approving the use of the advertisement. The average cost per square foot of his home sales is $275. In order to test his claim, you collect a sample of 1,001 home sales for the Pacific region. So a couple things that we hear there is that his average is $275. We have a sample of the Pacific region, and what we're going to do is test to see if that mean, the population mean of the Pacific region, is less than his average of $275. If that's the case, then we could say that his sales are higher than the Pacific region and he can move forward with the advertisement. So remember what we're looking at. We're not just looking at the numbers. We're not just looking at p-values and alphas. We're trying to decide if he can use that advertisement. That's the business aspect of this. So let's go down to the prompt. Design a hypothesis test and interpret the results using a level of significance alpha equals 0.05. Here we have our house listing price by region. This one has it where each of the tabs is broken up into region. To help support your work on this assignment, you may also use descriptive statistics in Excel and creating histograms in Excel tutorials. Those are just general tutorials. We'll go through a little bit detail in Excel for our specific assignment. Specifically, you must address the following rubric criteria using the Module 5 assignment template. I want to clarify, there's still like figuring out some of the details between the template and the prompt. So I just want to make sure you guys use the template and the sections provided, but you need to use this prompt to know which information to include. The template is just a guideline. This is what you need to include. You need to be hitting on these specific bullet points. So make sure you're looking at the prompt and not just going through the template. All right, let's take a quick look. So first we have the setup. We need to define your population parameter, including hypothesis statements, and specify the appropriate test. So first you need to define your population parameter. What population parameter are you testing? Are you testing the mean? Are you testing a sample? Because a lot of people I've seen in the past have said that their 1,001 observations are the population parameter. No, the parameter is going to be the mean. The population is the Pacific region, right? The mean price per square foot. The 1,001 observations that we're sampling, that's our sample. That's not a population parameter. That's our sample. Write the null and alternative hypotheses. Note, remember the salesperson believes that his sales are higher. I'm going to go ahead and give this one to you guys. I want to make sure you guys get off on the right foot. So when we're saying that we think that the sales, oops, helps if I have my pen on. The salesperson is higher. So let's remember that. Salesperson average higher. That's what we're testing. So remember, the first things that we have to do are, the way I think of it usually is I define our alternative or what we're testing, and that's what we're testing. So our null is that the mean is equal to 275. That would be the same. That's if the Pacific region is the same as the salesperson. Remember, your null is always going to be equal. Now the alternative, in this case, we're testing to see if the Pacific region is lower than the salesperson, right? Because he's saying that his number is higher. So that means we're testing to see if the population, the sample, we're going to use that sample to prove it, but we're testing to see if the Pacific price per square foot is lower than what the salesperson claims, 275. Or actually, those are his results. He's claiming that it's higher. This is important. You need to get off on the right foot in order to be able to do this correctly. Now remember, it says identify if it's a left-tailed, right-tailed, or two-tailed. Remember, when your alternative is greater than, that's right. When it's not equal to, that's two-tailed. And if it's less than, that means it's left-tailed. All right? These are important things in order for you to do the rest of this report correctly. So I think it's important that you know these things. All right. says identify your significance level. I'm not going to say it, but it's right here. Make sure you include it there. All right, data analysis preparation. So we need to provide the descriptive statistics, we need to provide a histogram, and we need to describe your sample. This is another important thing that people leave out. Describe your sample by writing a sentence describing the shape, center, and spread of your sample. That means when we're looking at our histogram and descriptive statistics, what do we see? And then determine whether the conditions to perform your identified test have been met. So first, let's go over to our data. So here is this housing data. I want to point out, I will not be doing it for the full 1001 observations. The reason for that is that you're supposed to be you would be getting the same answers as me. I'm going to run a sample of the Pacific. That way it's a little straightforward. So here's the full 1001. I've already generated a very small 50 observation sample from that Pacific region. You are not supposed to generate a 50 observation sample. I only did this so that I can show you how to do some of these tasks, but not give you the exact answer that you're supposed to get. All right, I just want to make sure that's very clear. So let's go ahead and do our summary statistics. So we have mean, median, standard deviation, right? So we're going to say equals average. Oops. Average, and we're going to highlight. We're only looking at cost per square foot. We do not care about listing price. We do not care about square foot at this point. We're only looking at cost per square foot. So there's our mean, and then our median is going to be the same group of data. And then our standard, remember, even when you're working with 1001, that's still a sample, so you still need to calculate the standard deviation as if it's a sample. So that's stdev.s. Remember, that's for the sample. Same column. Again, you could have also just typed in the range if you wanted, whatever's easiest for you. So that right there is our summary statistics. Again, you should just insert this table. You should not write the summary statistics in a paragraph. It should be included in a table like this. Make sure it's labeled. So you can put pot cost per square. Helps if I can actually see what I'm typing. Something like this. You need to have your columns, your rows labeled. You need to have grid lines. Make it very easy to read. I want you to think about if you're submitting this to that salesperson or even that salesperson's boss, they just want to like look through and find the key points. If they have to read through a paragraph to find some of this, they're going to miss it. So it's important to just make certain things easy to find. All right, so that's our summary stats, and then let's do our histogram. So we're going to go ahead and go to insert. Remember, we have our chart here, histogram. If you don't have this, you can also go to data and use the data analysis tool pack. So we're going to go and go to histogram. Oops, helps if I actually highlight that column first. So let's go ahead and highlight those values and then go to insert. Histogram. There we go. Now you should also update this. To say histogram price per square foot or something along those lines. And if you have this is really a problem, you can always change the orientation for the numbers here. Here, this one looks fine, so I'm not too worried about it. So there's our histogram. Now let's go back to our prompt and see what it asked us to talk about with regard to the histogram. Describe your sample. Now, I'm not going to get into too much detail here. This is something that you guys need to do, but is this normally distributed? Is it symmetric? Is it skewed? Is it left or right skewed? Is it really spread out? Is it like, look at our standard deviation compared to the mean and median? What would you say about this data? It's important to put that part. All right. The next thing it says is determine whether the conditions to perform your identified test have been met. Well, we're doing a t-test. So just to make sure you guys understand, and I probably should have mentioned this earlier, remember we do a z-test when we know the population standard deviation. That's extremely uncommon because if we know the population standard deviation, we probably know the population mean, and then we wouldn't need to run a hypothesis test. We run a t-test when we don't know the population standard deviation, which is significantly more common. So in this case, we are running a t-test. We don't know the population standard deviation. We just have this sample of 1,001 observations. So from the, this is the PDF lesson that I uploaded on in the week, the announcement this week. This information is all in Zybooks also, but just remember that you have this PDF lesson if you want to print it out and have it next to you on your desk or wherever you're working as a reference tool. Because I'm not going to say I'm old, but I'm old school where I like having a book or something next to me to help reference. So here in that lesson and also in ZBooks section 5.2, as you can see, we have the conditions for the t-test. So we have, I'm not going to go into too much detail. We have randomness, independence, and normality. So randomness is basically that you have a random sample. We already said that we assumed it's a random sample. Independence, you need to talk about if each observation should not affect other observations. So would the price per square foot of one home necessarily affect the price per square foot of another home? Normality, the t-distribution can be useful if the underlying population distribution is approximately normal. In most cases, the normality of the underlying distribution cannot be determined. Thus, the sample size determines whether the t-distribution can be used. So again, your sample size comes into play here, and you should be mentioning that when you talk about the conditions. All right, so let's go down to calculation. So we needed to determine the appropriate test statistic, then calculate that test statistic. So in this case, we've already identified that we're doing a left-tailed test. So the first thing we need to do to determine our test statistic is remember, let's go back actually over to our lesson. We've got our formula right here. This is also a really great little summary box, and I'm a big fan of these. It explains all the hypotheses, and then it tells you what you need to do and take the steps. So in this case, here's our formula for calculating the test statistic, that t. It's x bar, which is our sample mean, minus mu naught. A lot of people are writing u or something else, and this is a mu. This is not a u. It's a Greek letter. You'll see me type it as mu. But here, or you can insert that Greek letter. Depends on how you, what software you're using. Anyway, that's a sidebar, sorry. That mu naught's that number right here. So that's the number that we use in our hypotheses. That's that 275. Then we have our sample standard deviation divided by the square root of n over here. So let's go back to here. So let's do test statistic. We're going to say, and I do it in Excel. It just makes it easier for me, but you can do that in a calculator also. So we already found our sample mean. That was 238. Subtract that 275 from our hypothesis divided by our standard deviation divided by square root. Now, in this case, remember your number of observations, your n is bigger. It's 1,001. Mine's 50 because I made a little sample. All right, again, my numbers are going to be different than what you see. So there's my t-stat. That would be my test statistic. And do we need to find our p-value at this point or just the test statistic? Oh, calculate p-value. All right, so p-value is going to equal t dot dist. Now, this would be different if I was using a right-tailed test or a two-tailed test, but I'm doing a left-tailed test. So we use t dot dist. Our x in this case is our t-stat. The degrees of freedom is n minus 1. You will have 1,000, or you should have 1,000. Mine's 49, and we're going to say true. Enter. So my p-value is 0.0453. Again, you guys should not be getting this answer. If you get this answer, I know you went and did my, pulled it from my work. So definitely make sure that you're doing your own work on this part, on all of it. All right, so we found our p-value. Note for right-tailed distribution, that's just telling us which one. So use the normal curve as a reference to describe where the p-value and test statistic would be placed. So let's go over here. And let's look, I'm just going to draw it out. Now you can easily pull, or maybe I'll even see if I can find one to provide for you guys, a blank like curve. It doesn't have to be perfect. Just something like this, and also make sure it's bell shaped like this. I've seen a few where they're like that. That's a parabola. That's not a bell shape. So it should be a bell shape for sure. All right, so here our t distribution or normal distribution is centered at 0. So we need to find where our T-stat is right there. So our T-stat, so if this is 0, our T-stat's going to be somewhere over here. So we have -1, -2. All right. So negative